Assalamu alaikum. My name is Abdullah Ali Noor. I'm from Somalia. Currently, I'm staying in Kuala Lumpur. My metric number is A20EC 9116.
Hello, doctor. This is Ahmed Nasser from Astara. My metric number is A20EC3013.
Hello everyone, my name is Mohammed Sabi Rahman and my metric ID is A21EC0267.
Hello doctor, my name is Ryan Lim Shen and my matrix card is A21EC0223.
Hi, my name is Muhammad Syamil bin Saleh. Matrix number A21EC0208. I'm from group 3.
My name is Abdullah Ali Noor. Today, I wanted to explain for a project code that is a simple program converting for 4-digit hexadecimal into 2 segment of hexa. So for this program, in our main data, we have 5 string as you can see on the screen. So for this 5 string, the first one is please enter the digit or the 4-digit of hexadecimal, for example, A1 P2. Second is string 2, second complement of hexadecimal. When we run our code, when you enter it, he will give you the second complement. So string 3 is byte 0, byte is 0. So and we have string 4 that is try again, yes or no. Then in string 5 we have byte, the input value is not hexadecimal. So also in our main data we have val1 byte 10 cube. That means making val1 with 10 arrays. This file we make like 10 arrays, only 10 arrays. And var2 we have stored the length of character array, and this is yes byte. It means like this also these two are like testing the yes and initialize string no, initialize string yes. uh, if we talk about the carry byte, is verify whether propagation has occurred or not, and this is the highest 50 is the highest character to read for our program. And we have string byte highest deployment. So in this one it is null, it is wrong now. If we start for our main code, here we use L, like L, it's standard for while. So in this L, we have move edx offset string 1. If we explain a little bit more, it is move into a register. We move for edx to the register from string 1 using offset. So address is a way of handling the overloading of the move instruction. And we have call write string. In this call write string is only displays the string 1. The string 1 is please 4-digit hexadecimal integer. So then again we move the edx to the into register from val using offset again. So always when we move edx, we move it to the register we use using for offset. It always handling overloading for moving instruction. So for that one, move ECX size of file 1. For here, move into size is used to find the length of file, and it will move ECX to register. So again here, call call string, read string, call read string. So again, we use again the same display the string one. So that is, so they are same for that part because it's always bagged the definition they are same, for the definition they are same the word of the definition. And here we have invoke string case, and for this one is produces to convert it to string all uppercases and all uppercases character. In here we have move easy offset val, and that means store the address of first member of val. If we talk about first member of val is please enter the hexagonal digit. So move ECX 3 and to set, it says set loop for var to 3. That's it. And next person will explain it the rest.
Hello guys, this is Ahmed Nasser from Group Astra, and today I will be explaining my part regarding the CEO project. So I will be starting from the first complement. MOV AL byte BTR is ECI plus ECX. Here we take the first character and move it into AL. CMP AL 53. 53 is a decimal. If converted to car, it's 5. And we will compare the character with 5 in the car in ACSI. JA first complement number. So if AL is greater than 53, jump to the first complement number. If AL is smaller or equal to 53, means that the number is smaller or equal to 5. So going to the next code, SUP AL48. So 48 is decimal. If in character is 0, subtract the AL with 0 in ACSI to get the distance between the two values. So going to the next code, MOV BL70 SUP BLAL jump plus. Move 70 into BL 70 decimal. If the car is F in ACSI, this we will get the result of first complement, and then we'll jump to plus to contain the second complement step. So going to the next code, first complement number, CMP AL57. If AL is smaller or equal to 57, mean that the number is smaller or equal to 9 but bigger than 5. Going to the next code, JA first complement alphabet sub OL54. If AL is smaller than 57, jump to the first complement alphabet 54 decimal. If in car is 6, subtract the AL with 6 to get the distance between the two values. MOVPL 57. Move 57 into PL 57 decimal if the car is 9 in ACSI. So going to the next code, sub PLAL. This we will get the result of the first complement. So going to the next code, GMP plus. Jump to pulse to contain the second complement step. First complement alphabet CMB AL70. So if AL is smaller than 70, means that the number is smaller or equal to F but bigger than 9 from A to F. in ACSI. If AL is bigger than 70, jump to AXI2, mean that this is alphabet bigger than F, so invalid in ACSI. So going to the next code, SUPAL65. 65 is if any car is A, subtract the AL with 65 to get the distance between the two values. Moving to the next code, MOVPL53. Move 53 into PL 53 decimal if in car is 5 in ACSI. So going to the next code, SUPPLAL JMP plus. This will get the result of first complement, jump to plus to contain the second complement. So going to the plus, TMP ECX3 GNA propagation. So this code to check whether it is MSP or not, because only add one to the MSP. If not, the MSP will directly skip load to step 2 propagation. So yes 9, CMP will PL57. This is to carry a bit propagation only occur if the digit is F. First compare it is 57, 57 decimal is 9. In CSI, if it's 9, it will become E. So going to note 9, CMB PL70. This is to compare if if 70 is CSI table or not. If it is F, it will become 0 after adding 1. So going to add BL1, add BL1, add BL with 1 and nothing to be to concern to carry a bit. Since the hexa value is not F, so no carry bit doesn't jump to Sambang. So at the end and the last code, propagation. So after in this code, after adding 1, we will check whether there is a carry bit propagation or not. If there is no carry bit, jump back to YAS9 to check the next digit. At the last part is Sambang. Here we take the next character and move it into PLES. I contain the value in Pericatan. And then ECX is to refer the offset of the ESI location using the little Indian order as we using in a byte. And decimal ECX will be used to update the loop counter. We need also to decrease because since we reverse in the stack, compare ECX with -1. If equal jump exit 0, to exit the next step. If not, reloop again and jump to the first complement. Okay, I'm done, guys.
Here EX1, we move into the register EDX from Krakatan using offset address, and is a way of handling the overloading of the offset and then the move instruction. Then display these two's complement here. Then call CR5 is for new line. Then jump to EXI, ask user want to try again or not. Then EXI2 here, uh, we move into register EDX from prompt 4 using offset. For this is for addressing and is a way of handling the overloading of the move instruction. Then call writing string we use for display the prompt for error message. Then call CR5 is for new line. Then jump EXI asks user want to try again or not. Then here EXI, we move into the register EDX from prompt 5 using offset. Then address and is a way of handling the overloading of the instruction. Then call write string is for displaying prompt 5 to try again, yes or no. Then here move edx of offset input string we use for moving to register edx from input string using offset. Here move ex max for move max into ecx. This is the library for user input. When using read string is it's stored at register edx. In invoke str compare, here str compare is to compare two null terminated strings. This compare user into input with the test1 equal to y. Then jump to no if not equal. Then it's new line. Then jump back to while y. Then for no invoke str compare here, str compare is to compare two null terminated strings. This compare user input with test1 equal to n. Then it's jump to other if not equal. Then it's new line. Then jump here to terminate the program. Then here for other call crfi. Then it's for new line. Then new line. Then move into register edx from prompt 6 using offset. And then display prompt 6, then call crlf for new line, then new line. Then we have to press enter, then clear screen, then jump back to exi for the proper code enter. Then for here, press enter, then it will clear screen and exit the program. Thank you.
Our main code of 4 digit of hexadecimal converting to the two's complementary. So that is our code. And first, if we build for our code, build for our project, there is no failure or something. There is no error. And if we run it, uh, we will see it for this thing like please enter 4 digit of hexadecimal integer, for example, A1, B2. If we enter it A1, B2, uh, we will get it the result in second complement. As you can see, uh, A1, B2 is 5E, 4E as a second as two's complement. If we say yes, uh, he will give us, if we say y, for meaning yes, it will give us enter again a new number. So if we give like a new number 5f 5f 44, we will get it this towards complementary of hexadecimal 0 A0 BC. So if we say no, if we click it no, it says press any key to be continued. So that is the main output of the project, and thank you for watching this video.
For the reflection, I will first start with what we have learned from doing this group project. From this group project, we have learned more about assembly language in general, and we get to expand our skill in terms of writing assembly language. Since this is our first time learning assembly language, it is a very thrilling experience for us to learn more about the computer world. Another thing that we have learned from this group project is that we learn to communicate better with our group mate and also learn the importance of good communication skill. Because good communication skills can lead to better teamwork, which overall help making the whole group project easier. There are two main challenges that we face throughout this whole group project. Number one is that we do not have enough experience in writing assembly language, and number two is that we have different time zone between our group members and for local students, because some of the students are from other countries, so the time zone doesn't match and it causes a little bit of disruption in terms of communication.
So the way that we overcome the challenges that mentioned by Ryan are, firstly, we learn and discuss together on how to make this project a success. We give ideas and help on what is needed together. After that, we have we have different time zones between group mates, and to overcome this problem is we discuss and tolerate on what time does everyone is free, and we do the project together.